We're going to add silica to the small beaker. We're estimating how much to use. The silica dust is very bad to breathe, so we're using this in the hood. Yeah, you can see very fine dust. So probably one or two more scoops like that. Okay, let's take a look at the beaker now. Yeah, I think that's sufficient. So we'll go with that amount. We're now going to add the solvent. In this case, it's 80% hexane, 20% ethyl acetate. And we need to add enough so that all the silica will get wet and a little bit of solvent left on top, but not a vast excess of solvent. So, more than that. More than that. Probably more than that, yeah. So it should be that when you swirl it, the silica moves. So it's fluid. Alright, so maybe about 10 more milliliters. Alright, that might be enough. Yeah, okay, so this is what's called a slurry. You can see that the silica moves, but it's kind of slushy. And that's ideal. So we're now ready to load the column. We're going to use sawed-off pipette technology. So this is a normal plastic pipette, clean, brand new from the box. Alright, we're going to cut off the pipette so that it has a wider opening. Right about there. Okay, so that's how it should look. So here we have a column. At the base of the column there's a cotton plug that will keep the silica in the column while allowing solvent to go through. This looks pretty good, yeah. So it's certainly slushy, it's not overly fluid. You can pull up silica in your pipette and you can deliver silica with some solvent as well. Yeah, so that looks just about ideal. And you do need to keep stirring it to get the silica suspended. Alright, so into the top that goes. Alright, so that you can see the possibility of trapping air there. So a little more fluid, a little more fluidity will help. Okay, I think that looks pretty good. Let's see what that looks like. Yeah, that looks about right. Okay.
I put that much in.
Yeah, you're going to fill it up to about here.
Kenji quit.
Here's a close-up. We've got solvent on the top, nice smooth silica all the way down to the bottom. That's the way it should look.
Okay, that's good.
So here we have about 20 of the baby tubes. These are 75 millimeters tall. And that's the best size for collecting fractions is what we're going to do. And Morgan's demonstrating how you could have the drips go into one tube and then shift it to the next tube.
Yeah, maybe we'll have to.
Before we load, we're going to drain the solvent so there isn't any solvent on top of the silica. But you have to have your fraction tubes ready before we load. This is 300 microliters of sample loaded on top of the column, and we're about to drain it into the actual silica.
So when it was all one, here we added 3. We put it in there, we separated into top and bottom. We added 1.
Okay, that's it. Alright, so sample's now in the silica. Gently add solvent on top.
Yeah, like spray it kind of slowly around the edges.
Yeah, just a few drops is all we need. Get the tip of the pipette down low. Okay.
Thank you.
Yeah, okay. So add your drops. Add a few more drops there now, Reese. Just a couple. Alright. Okay, so let's drain that into the silica now. That looks great.
Okay.
So in theory, this should be making it sort of a clean layer on top. The first top millimeter of silica will now be clean because your molecules have been pushed in.
Okay.
Alright, so repeat that. Okay, good. So let's put that into the silica now.
So far you've added 6 just to the top.
Okay, great. Okay, so now you should be able to load a bigger solvent on the top, and you start collecting fractions seriously.
Yeah, because you said the first one.
The first one won't have anything in it. So
So
the first one could be a big fraction.
Like, I mean, most of the test tube.
It could be half a test tube's worth, yeah. Sure.
Okay.
That would be a reasonable thing to start with.
So
Okay.
add more now?
Yeah, like start slowly again at first. Much more, just so we don't have to worry about it going below the silica.
Right. Okay, so you can open the tap now, Morgan.
Okay.
And Reese will add more solvent.
As
Okay.
needed.
You'll just more solvent. So we're no longer trying to get it to go
Okay,
beach
so-
sand dry. We're trying to say it never gets close to that.
Yeah.
There's always a nice layer of solvent on top.
How come Brock moves so slowly?
I can't answer that.
You don't know.
All right. So this is now collecting fraction number 1, big fraction at the bottom.
I just want to let you know.
So,
I'm just sick of Dylan Bush trying to be all obscure.
This is a nice flow rate.
Historical anecdotes.
You can see drip, 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 drip. So we probably have about 1.5 mils per minute. That's a good flow rate.
I wish there were options to take creative writing classes or journalism instead of English.
I wish there was like.
Right, so you can be very more generous on the top there, Reese. And,
AP write about someone else's stuff.
yeah.
I feel like that should be.
There's no danger now of disturbing the sample. It's already
okay.
an inch into the column, so no danger of disturbing it. So just keep that solvent full, and you probably should now start collecting real fractions, Morgan.
I'm gonna get my camera.
6.
Oh, you mean in college?
All right, so what we'll want to do next is prepare.
So, after this amount, I should just move it over again, right? Isn't that about...
Yeah,
Okay.
yeah, that's a good size fraction. All right, so that is a reasonable sized fraction there, and we're collecting the second series fraction, the third total fraction. After running my column, or even during the running of the column, I'm collecting many fractions, and I want to be able to do a quick screen. Is there anything in any of these tubes of interest? I can do this with one plate, one microcap. Let me demonstrate. On the plate I put numbers 1, 2, 3, 4, 5, 6, 7, 8 all the way up to 15. Here we go. I'm going to use 1 microcap, fraction number 1, get a little bit in the microcap, put a spot for fraction number 1, expel the remaining contents. So I'm getting rid of the remaining contents. Now I'm going to 2. The amount of cross-contamination I'll get with this is minuscule. There's a spot for fraction 2, empty the contents. Fraction for spot for fraction number 3 is next. So you can see I can do many spots in a minute, and I just put 1 spot for each fraction. Size of the spots, not important. I'm just seeing, is there anything in there? I am using the bulb to help me here. The bulb has a hole. If I push, cover the hole and push, if I cover the hole and push, I'll get rid of everything in the pipette. So I've spotted fractions 1 through 13 on my plate here. If my molecule is UV active, all I need to do is look at this in the UV light and see, is there anything in any of these tubes of interest? This is the plate on which I spotted 13 fractions. I will now stain the plate and hope that I get useful information. Alright, so this is great. I can see that certain fractions have material that's worth investigating. Fractions 1, 2, 3, 4, 5, 6, 7, 8 are useless, but 9, 10, 11 have something of interest, and looks like 13 also has something of interest. So the fractions of interest are worth running on a real TLC plate that I developed to see what molecules these actually are. Here I have my plate for staining. I'm using the spray bottle. It's in the box. It's got paper towels 3 or 4 layers thick on the bottom. I spray until the plate is saturated, and then I heat on the hot plate. Here I have a column that I need to empty now. It's used, it's served its purpose. The valve is open. I have a rubber bulb from T2. I have a beaker to collect the silica waste. I push it out. There we go. Need some residual cleanup, but most of the silica is in the beaker.